So, these are the selected key terms from this chapter. So, first one is electron. Electron is the basic particle of negative electric charge. When we say electrons, it is a negative charge. Valence. A valence is related to the outer shell of an atom. When you say valence, it is related to the outer shell of an atom, wherein ang outer shell natin of the atom is what we call the valence shell or a valence band. So, free electron. An electron that has acquired enough energy to break away from the valence bond of the parent atom, also called a conduction electron. So, ang free electron, yan yung electrons na nag-leave from the valence bond to the conduction bond, kung saan tinawag din natin itong conduction electrons. Conductor. Ang conductor is a materials that easily conduct electrical current. So, ang conductor has an electrical charge known as the electrons that can move freely. That's why ang conductor can conduct electrical current. For the insulator, a materials that does not normally conduct current. The insulator, these are the materials that does not conduct electricity. That does not conduct current. Kasi nga, ang insulator, they are tightly bound to the atom. So, we have this semiconductor. A semiconductor is a material that lies between conductors and insulator in its conductive properties. So, semiconductor is neither a good conductor nor a good insulator. Crystal, a solid materials in which the atoms are arranged in symmetrical pattern. Hole, the absence of an electrons in the valence bond of an atom in a semiconductor crystal. Itong hole na to, this is the valence left with the valence electrons. We're going to leave the valence bond to the conduction bond. So, mayroon tayo malaleft na valence vacancy, rather, at tinatawag natin itong hole. Diode, a semiconductor device with a single p-in junction that conduct current in one direction only. Where diode is the combination of the p-types at saka n-type, and it has a region in between them known as the depletion region. P-n junction, the boundary between two different types of semiconductive material. Barrier potential, the amount of voltage required to produce full conductions across the p-n junction in forward bias. When we say barrier potential, yan yung nagsastop sa charge of migration. Forward bias, the condition in which a diode conduct current. So, for the forward bias, it allows a current for a p-n junction to flow. So, forward bias is meron tayong current na magpa-flow. Reverse bias is the condition in which a diode prevent current. Compared dito sa reverse bias, it will block the current. There is no current that will going to flow. Therefore, ang reverse bias, ang current nito is I is equals to 0 ohm. So, these are the problems or questions from this chapter. Example, question 1. A semiconductor is a crystalline material with letter A, many free electrons held by the attraction of positive ions. Letter B, strong covalent bonds between neighboring atoms. Letter C, only one electrons in its outer shell. Letter D, a filled valence shell. So, ang answer nito is letter B. Yung semiconductor in a crystalline materials is a strong covalent bond between a neighboring atom. So, nakaprovide tayo niyan ng example in which we have this antimony at saka ng silicon. They are bonded to each other. So, where they share electrons with their neighboring. Number 2, question number 2, a metallic conductor has letter A, many free electrons held by the attraction of the positive ions. Letter B, covalent bonds between neighboring atoms. Letter C, 4 electrons in its outer shell. Letter D, a filled valence shell. So, ang answer dito is a metallic conductor has letter A, many free electrons held by the attraction of the positive ion. Alam naman natin na those conductor has free electrons that can move freely. And number 3, in a semiconductor, the concept of an energy gap is used to show the difference between the energy of the letter A, nucleus and outer shell electrons, letter B, nucleus and the free electrons, letter C, conduction band electrons and valence electron, letter D, core electrons and valence electron. So, letter 3, ang question dito is, ang semiconductor daw, in a semiconductor, the concept of an energy gap is used to show the difference between the energy of this one. So, kapag yung valence bond natin, ang sagot dito is conduction band electrons at saka valence electrons, letter C. Kasi, kapag yung electrons natin will have an additional energy, it will start to leave the valence band papuntang conduction band. So far, ang answer dito is letter C, conduction band electrons and valence electrons. Number 4, an impurity such as antimony Sb element has 5 electrons in its outer shell. When silicon has Sb impurities, letter A, N materials is formed. Letter B, the crystal will be negatively charged. Letter C, both of the above. Letter D, none of the above. So, ang sagot dito, an impurity such as antimony has 5 electrons in its outer shell. When silicon has a Sb impurity, letter A, an N materials is formed. So, na-example, na-given natin ito na example, na-provide natin na itong example kung saan napakita natin na ang Sb, ang antimony, has 5 electrons. Then, it is bonded to a silicon. Pero itong antimony has 5 electrons kung saan ang 4 electrons niya is gibond niya sa silicon. While, mayroon tayong natitirang isang electron kung saan tinawag natin itong extra electrons. That's why nakaka-form tayo ng N material. So, ang answer dito is letter A. For number 5, compared to a P materials, the energy level in an N materials are letter A, the same, letter B, greater, letter C, lower. Ang answer dito is letter C. Ang N material is lower sa P material. And again, ang energy level sa N materials is lower than this level from this P material. So, number 6. When a P-in junction is formed, electrons move across the junction and fill holes in the P region. The filled hole is A, neutral atom, B, minority atom carrier, C, positive ion, D, negative ion. So, again, when a P-in junction is formed, electrons move across the junction and fills hole in the P region. The filled hole is, ang answer dito is a negative ion. So, makaka-create tayo ng layer of the negative ion or what we call the pentavalent ion. So, what we call this one, the trivalent ion. Makaka-create tayo ng layer of negative. So, ang answer dito is letter D. For the number 7, the forward bias ni voltage in a semiconductor diode is approximately equals to the letter A, bias supply voltage, letter B, breakdown voltage, letter C, output voltage, letter D, barrier potential. So, ang sagot dito is letter D, barrier potential. Forward bias ni voltage in a semiconductor diode is approximately equal to this barrier potential.